13, we're taking a look at some of the figures that we've been studying, quadrilaterals and triangles, and we're placing them in a coordinate graph, and we're proving that they are a particular type of quadrilateral or a particular type of triangle. So starting with number 2, we're given some clues. Let's take a look at the side lengths. We have 2 side lengths that are congruent to each other, and those 2 side lengths happen to be opposite one another, AB and CD. So if I were just to draw a really easy sketch here, just a really simple sketch, if I had A, B, C, D, right now I know that AB is radical 8, and CD is also radical 8. So I have one pair of opposite sides that are congruent. I also notice that the other pair of opposite sides are congruent. Obviously not drawn to scale, but we notice that BC is radical 32, and DA is also radical 32. So what I have is I have opposite sides are congruent. Let's go through our list and let's check off what we know for sure it cannot be. It cannot be a trapezoid. It cannot be a rhombus, because what we know about a rhombus is all the sides are congruent. It could be a rectangle. That's a possibility. We know it can't be a square, because in a square, again, all the sides are congruent. And so, by process of elimination, we're going to say that this is a rectangle. But just to make sure, what we know about a rectangle is we have 4 90-degree angles. So to check to see if we have 4 90-degree angles, we're going to look at the slopes. So the slope of AB has a slope of -1, which means down 1 and over 1. The slope of, we'll call this AB, the slope of BC, is positive 1, which means it goes up 1 and over 1. Let's see, BC was a little bit longer. So the slope of BC is positive 1. And so when we have slopes of -1 and positive 1, because they are opposite reciprocals or negative reciprocals of one another, then those 2 segments do indeed form a right angle. So because we have a right angle formed with segment AB and segment BC, and we also have 90-degree angles formed with the other segments, we can definitely say that this figure is a rectangle. In number 4, we have 4 completely different lengths. So let's take a look here. Because all 4 sides are different in length, it cannot be a rhombus, cannot be a rectangle, nor could it be a square. So the only thing it could possibly be is a trapezoid. If it's a trapezoid, 2 sides must be parallel to each other. So 2 sides must have the same slope. So let's take a look at all the slopes. And I notice that of all the slopes that are given here, none of these are the same. So therefore, we have no parallel sides, we have no congruent sides, so this figure is none of the figures listed above. All right, the directions for number 6 are right above here. We have to classify the quadrilateral as being a trapezoid, a rectangle, a rhombus, or a square. And then we need to justify our reasoning. We're going to be using the Pythagorean theorem and the slope formula to show that the figure that we think it is actually what we say. So we're going to begin by plotting the points for A, B, C, and D. Point A is at 0, -3. Point B is at -4, 1. Point C is -6, -1. And point D is -2, -5. So we're going to first find the distances for all 4 sides. We're going to find the distance from A to D, from D to C, from C to B, and from B to A. And to do that, I'm going to use the Pythagorean theorem. So we're going to start with A to D. And if I use the Pythagorean theorem, I have 2 squared plus 2 squared is equal to C squared. So C squared is equal to the square root of 2 squared plus 2 squared. And radical 8, if I want to simplify, is simplified into 2 radical 2. To find the distance from D to C, I can draw another right triangle. 4 squared plus 4 squared is equal to C squared. So the distance from C to D is equal to the square root of 4 squared plus 4 squared. And radical 32 can be simplified into 4 radical 2. And we'll do the same thing from C over to B. And from B to A. So what we've shown is that we have one pair of opposite sides congruent and another pair of opposite sides are congruent. So either the figure is a parallelogram or possibly it could be a rectangle. Now in order to see if it's a rectangle, I need to see if the slopes formed are opposite reciprocals. So we're going to find the slope of each side. We're going to find the slope from A to D. We're going to find the slope from D to C, from C to B, and from B to A. And because I'm finding the slopes, I need to note that. All right, and just to remind ourselves, the slope formula is the difference in y's divided by the difference in your x values. So let's start with the slope from A to D. So I'm going to take my two y values, -3 minus -5 is -3 plus 5, divided by 0 minus -2 is the same as 0 plus 2. All right, and that looks correct because as I mark it off here, I notice that from D to A, I go up 1 and over 1, up 1 and over 1. Now we're going to find the slope from D to C. So from these 2 points, I'm looking for the slope. And so I'm going to do y minus y. So -1 minus -5 is the same as -1 plus 5. And then -6 minus -2 is -6 plus 2. And that looks reasonable too, because from C to D I go down 1 and over 1, down 1 and over 1, down 1. So the slope is -1. The slope from C to B. 1 minus -1 is the same as 1 plus 1. -4 minus -6 is -4 plus 6. And so therefore the slope of CB is +1, which leaves the slope from B to A. So -3 minus 1 divided by 0, 0 minus -4 is 0 plus 4. And that gives me -1. So what we notice is that we have opposite reciprocal slopes. And opposite reciprocal slopes. So that means all of these are right angles. And so we have, number 6 is a rectangle. Opposite sides are congruent, and all angles are 90 degrees because all sides are perpendicular to each other. All right, let's take a look at number 8. In number 8, we plotted a kite, and as you can see, the points are shown in the diagram. And we want to prove that this is a kite. So one of the ways that Tom said this is a kite is that he showed in the diagram that the diagonals are perpendicular. So QS is perpendicular to segment PR. And that is one of the properties of a kite. So now, what other information about the diagonals? So let's just highlight the diagonals right now. Take a look at the diagonals. What else about these diagonals are true in order to state that this is a kite? Well, one of the things that we know about the diagonals of a kite is that one of the diagonals bisects the other diagonal. In this diagram, PR, segment PR, is bisecting segment QS. In other words, segment PR is cutting segment QS exactly into two equal parts. So we would also need to prove that QM, segment QM, is congruent to segment MS, or better stated, I should say, that the length of QM is equal to the length of MS. And in order to do that, I have to state which formula to use. So to find whether QM is equal to MS, I would need to use the distance formula, or I can also use the Pythagorean theorem to find the length from Q to M and the length of MS. Determine whether the statement is always, sometimes, or never true. The diagonals of a trapezoid are congruent. All right, I've drawn two different types of trapezoids. The first trapezoid is an isosceles trapezoid, and in this instance, the diagonals are always congruent if it's an isosceles trapezoid. In the second trapezoid, which is not isosceles, the two diagonals are not congruent. So number 10 is sometimes, depending on the type of trapezoid that I draw. Number 12, a square is a rectangle. That is always true. Square is always part of the rectangle family. Number 14, all angles of a parallelogram are congruent. Well, here's a parallelogram where all the angles are 90 degrees. But here is another parallelogram where all the angles are not congruent to each other. So number 14 is sometimes. diagonals of a parallelogram are perpendicular. Here's a parallelogram where the diagonals are perpendicular. That would be in a square. Square is a parallelogram. Here's another parallelogram where the diagonals are not perpendicular. So this would be sometimes, depending on the parallelogram.